Good morning again. Can you hear me? Can somebody please confirm?
Yes.
Okay. So we continue with the presentations. It's group 8 to present. Who's presenting from group
Yes.
8?
Yeah, I'm
Naresh.
present. Naresh is present.
Okay. You can start, Naresh.
Yeah. Is my screen visible?
Yes, it's visible.
Mm. So, good morning. I'm Naresh, and I'll be presenting on wing design for cargo aircrafts. And my teammates are Ashwin Sridhar, Seshat, and Sami Vasan. So, uh, the mission specifications which was given to us, as you can see, this is the mission specification which was given to us. So, you can go through it. So, moving on to the wing area. So, we calculated the wing area based on the previous results. So, we got a wing area of 295.334. So, and comparing it with our reference aircraft, we actually considered our aircraft to be high wing and a having a high wing and a tapered wing, and with a small swept angle. So, moving on to selection of airfoil. We basically used cruise at start and end for the range for CL. So this is the range which we got. We got from 0.37 to 0.44. And also we have assumed the maximum thickness ratio to be from 12% to 15%. So using these values, we actually selected four different airfoils. So, and we finally came up with a airfoil which is NACA 24112. So this is our airfoil, and yeah. Uh, so we actually compared four different airfoils using drag bucket. So as you can see, this small line which is bulging out here is our NACA 24112. So which has minimum CED. So yes, moving on to the graphs. So these are the three graphs which we got for airfoil. And yeah, this is a plan form view of a wing. Yes. And moving on to the sweep angle and the taper ratio. So we use these formulas to calculate the sweep angle to taper ratio. And also we use iterative methods to further calculate the respective values. So these are the values which we got. We got some taper ratio of 0.42, and yeah, these are the respective values. Uh, and moving on to other wing parameters like wing span, root chord, tip chord, and main aerodynamic chord. These are the formulas which we use. These are the values which we got. Yeah, I guess yes. Moving on to 3D lift coefficient. So these are the formulas which we use and which we used. So we got slope for 3D as 5.1 to 1, and this is a CL formula. Using this CL formula, we drew the graph. And also we took the slope for 2D graph. We took the slope for 2D CL, which is somewhere around 5.58. So instead of this 2 pi, we actually substituted 5.58 and calculated the values. So using the CL, we plotted graph. This is the graph which we got. So yes, the blue line is the 3D and the red line is the 2D. So yes, this is the graph which we got. And moving on to 3D drag coefficient, these are the formulas which we used, and these are the parameters which we got. So we got our base drag as 0.00754, and our Reynolds number as 3.3 into 10 to the power 7. So these are the parameters which we got, and using this CD naught, we actually plotted a graph. So this is a graph CL versus CD. So this red line is our 2D and 2D curve, and this blue line is our 3D curve. Yeah. So this is a graph which we got. That's it.
Okay, so let's wait for sir if he has any questions. Yeah, so Naresh, only one thing that's what as mentioned. You have used the quarter chord sweep calculation. So that iteration thing, you have to refer it here and also cite it in your presentation.
Yeah, sure. I'll do it in my report.
Yeah, sure. So that was the only thing, and everything else is fine. And sir has complimented on your presentation.
Thank you.
And any questions to Naresh? Okay, so if there is no questions, then we can proceed to the next team. Next group is
Group 13.
yeah, group 30.
Share the PPT.
Who is presenting? Divya Tejas.
Yes, sir.
Okay.
Is PPT still?
Yeah, it is visible. You can start.
Okay. So this is our mission requirements, and then these are the values we have obtained from the previous calculations. Using this formula, we found CL values. Using this formula, we found CL values here. And we compare three airfoils: Dela AG13, Naka 641212, and Naka 64206. Here, NASA 64206. This airfoil's drag bucket didn't match our required drag bucket, and then NASA 641212's thickness is very high, which is not suitable when we are having both Mach number both around zero point 0.9 and 1.5. So we went with AG13 airfoil. This is CL versus alpha graph. And then we have plotted it for around 6 different Reynolds number. And then this is CL versus CD graph with respect to Reynolds number. And then we considered our taper ratio as 0.2. From the graph given in Raymer book, we have taken the sweep angle using this graph, and we got a sweep angle as 48 degrees. And then with values of sweep angle and taper ratio, we can calculate CMAC, CRCT, sweep angle at T by C max, and such things. So these are the values we obtain using the taper ratio and sweep angle values. For 3D lift coefficient, we used these formulas and calculated, and we obtained these values. As same for wind drag estimation also, we have used these formulas, and then we have obtained values for both subsonic and supersonic Mach numbers, and these are the values respectively. Uh, from the data we have got, we have brought the plan from design for our wing. Thank you.
Okay, we'll wait for sir to ask any questions.
Okay.
Yeah, again the same thing, Divitesh. You have to cite your references properly in the presentation, and also from where you took this quarter chord sweep formula and that
Uh,
particular, and also
that we got from Corp.
yeah.
Actually, that we could cite it in the report.
Okay, yeah, that is also there, and also you have to include the references over here. Also cite it in the
Okay.
presentation.
Okay.
Otherwise, it's fine.
Okay.
And any questions to Divitesh? Okay, so no questions. Then thank you, Divitesh.
Thank you so much.
So next group to present. Yeah,
Hi,
it's group number
group
4.
4. Yeah.
Yeah.
So I'll be
Who is
presenting
presenting?
Akash.
Akash. Okay.
So is my screen visible?
Yes, yes. You can start.
Uh, Good morning, everybody. On behalf of Group 4, I'll be presenting the wing design, main wing design for our aircraft water bomber. So these are the design specifications, and the left side ones are the ones given to us by SIR, and the right side ones are collected from various reference aircrafts and our previous reports. And this is our mission profile. So wing platform area. So since we know the takeoff weight and wing loading, we found out the wing platform area to be 34.102 meters square. And airfoil selection. So we found out the 3D wing lift coefficient at the start and end of the cruise using the formula W by S is equal to CL times Q. And using that, we even found out for 2D wing, and the data are as shown. So airfoil chosen for comparison. So the first one we have gone with 4-digit NACA airfoil. So which is NACA 4412, and the maximum X by C, Y by C, and maximum thickness and camber details are as given. And the second one which we have chosen was a NACA 5-digit one, which is NACA 23015. And we plotted the lift curve for both the airfoils, and this is the drag polar for both the airfoils. So we have decided to go with knockoff 4412 because the range of CL lies within the drag bucket, and for this range we have a minimum CD, and on top of that for most of the water bomber aircraft go with knockoff 4-digit airfoil, so we have decided to go with this. And next is the 3D wing coefficient. So we have chosen our taper ratio to be 0.4 and swift angle to be 0 degrees. And our Mach number is 0.3. So from that we found beta to be 0.954. And since we are using the aspect ratio as 8.15, and substituting all these in the DCL by D alpha formula as shown, we found it to be 5.106 per radian. And from the 2D lift curve, we found out the angle of attack at 0 lift to be minus 1.1 degrees or minus 0.019 radians. So which gives us CL at alpha equal to 0 to be 0.098. And substituting all these, we found out the lift curve equation to be as shown. And using that, we plotted the lift curve for both 2D and 2D and 3D lift. And moving on to the base drag estimation. So since we have decided to go with the knockoff 4-digit airfoil, and we have taken the XPC maximum and TBC value from the previous slides, and Mach number to be 0.3, we found out the form factor to be 1.407. And we took this table from Corp book. And since we are going with a high wing, our inference factor will be 1. And since our maximum thickness is greater than 0.05, we got we got the S weight to be 69.55 meters square. And since our turbulent flow, our friction coefficient is 0.00363, which we got using the formula shown. And substituting all these values, we got CD naught to be 0.0104 and K to be 0.0488. And putting all these values in the drag polar equation, we found out the drag polar equation. And this is the drag polar plot for both the 3D and 2D wing. And these are the other platform geometric relations which will need for designing the. And we are yet to design the 2D and 3D wing, since we actually changed our aspect ratio from 5 to 8.15 at the last minute. So we'll upload that in the report. Other than that, that's all.
Okay, we'll wait for sir if he has any questions.
Yeah.
Yeah, Akash. So there's a comment from sir. Can you go to that airfoil? You plotted the airfoil. That's right.
Yeah.
No. Okay. Yeah. So here I think the scale is not proper. Is what sir has mentioned. That is why your airfoil looks thick. So you have to maintain proper like right scale on x and y axis, equal scale.
Yeah.
You'll get it in.
Yeah.
So this, and then in your later plots of CL and alpha, CL versus alpha. Yeah, in some plots units are missing. So
Okay.
yeah, so make sure that these units are in the alpha is in radians and not in degrees.
Okay.
Okay. Only then you will get the right slope.
Yeah.
Okay, so you check all the plots whether units are correct, and take care of the scale also. And in your 3D lift coefficient slope, you have to use the 2D lift curve slope instead of 2 pi. So 2 pi is according to thin airfoil theory. You
Yeah.
have the
Actually I have used the 2D slope instead of like I forgot to.
okay. What is that value you got for 2D lift curve?
We got it to be 5.35.
Okay, then fine. Okay. Yeah, and yeah, question from my side that you have calculated CD for your drag estimation.
Yeah.
Yeah, so you have to substitute the cruise. Yeah, yes. So you have to substitute the conditions at cruise and find the total drag on the wing. Okay, so
Yeah.
you substitute CL at the cruise, and you find and multiply the CD by half rho V square S V at your cruise velocity, and you know the plan for me also.
Yeah.
So you find the total drag on the wing. That also. Other than that, it's fine. So any questions to Akash? Okay, no questions. Thank you, Akash. Next group to present is group 6. Group 6, who is presenting?
I think this is
Hello?
It's Yuvraj here, group 6.
Yuvraj, okay.
Actually,
Yuvraj, you can.
we couldn't make it today, complete the, and we have an excuse for today because we are still with a few plots and so.
Oh. Okay, I just wait. Yeah, Yuvraj. So this is not an excuse actually. What sir says is you have to present whatever you have done, or even you can present orally how you proceeded with your wing design, and whatever difficulties you have encountered while doing this. You can share with us, or you can also read out, but you have to present. If you don't, then like you'll be getting 0. Also 0 for the group. This is the rule. So you can present whatever you have done, or you can even orally speak out.
Just a second.
Sanjay, is it okay if somebody who is already presented goes again? Because Sanjeev, his mic is not working, he said.
Okay, I'll just ask sir. Yes, sir. Yeah, so what sir says is since from your group Krishna and Ananta Krishna have already presented, you guys cannot present again. Either Sanjeev or Yuvraj can present this time. It's your choice. If Sanjeev presents today, his mic is not working, he can present and he can communicate through the chat. If Sanjeev presents the wing design, then Yuvraj has to do the fuselage design, which is going to be more complicated than the wing design. So the choice is left to your group. Fuselage design would be more difficult than this. So that Yuvraj has to do if Sanjeev is going to present the wing design. And presented already, cannot present again.
Okay, sir. So can we have 5 minutes to decide if Yuvraj can present now then?
Yeah, Krishna. So you can take some 2 minutes more. You have to present within that time. Or else, if you are not ready, you can present in tomorrow's class. But then 5 marks would be deducted from the marks what you get for the individual as well as for the group. Or you can even present now within 2 minutes. You get 2 minutes from now. Sanjeev can actually share the screen and he can communicate through someone else, like how Sir is doing through me. You can also communicate through somebody else, or you can communicate through the chat, whatever. If you want to present tomorrow, the next group can proceed, and then but then you'll lose 5 marks for out of how much you get for both the individual who is presenting and for the team. Two minutes from now, you can decide.
Sir, if it's okay with you, we'd like to present the full thing tomorrow after everything is done. It's all right if we lose 5 marks, if that's all right with sir.
Okay. Okay, so if so, with your consent, if you are ready to lose 5 marks for the individual and for the team, you can present tomorrow. And your team should be the first to present tomorrow. You can decide whether Yuvraj or Sanjeev, whoever is presenting. And if you don't present tomorrow, you will get 0 for both the individual and the team. So
Yes, sir, definitely. We'll present first thing tomorrow. So sorry for the inconvenience.
okay, so with this we can proceed to the next team. Group 9 is next. Is presenting from group 9.
I will be presenting.
Okay, you can start. Shamla. Shamla is presenting.
Is it visible?
Yeah, Shamla, just hold on for a second. Yeah, meanwhile, Sir has also communicated, I think that for the midterm Viva, he'll be concentrating more on fuselage design. So that portion is going to be included for the midterm exam as well as for the Viva. And questions will be from fuselage design. So that is more complicated. So can prepare that also. Yes, Shamla, you can start.
Okay. I will be presenting today on behalf of my group, which contains Satya, Nitin, and Raj. So these are our mission specifications. We had a short-haul regional aircraft, and we came up with this airfoil. We calculated the after getting the sonic speed, we calculated CL cruise, and then our airfoil was plotted as such. Ours is NACA 41014. And our planform area is as such. We got the S from here, and then we also got the wingspan. Our sweep angle was 0 because ours is nearing Mach number 4, and this is our taper ratio. Our CBAR, our mean aerodynamic chord position is 2.95, and this is the normalized span-wise location of mean aerodynamic chord from the center span. As I said before, our wing has no sweep. The 3D lift coefficient was calculated using the formulas, and we got M effective of 0.42, which is the same as M infinity, since our in leading edge sweep angle was 0. And The DCL by D alpha we got was 5.46. Our beta was 0.9075. That is it. We didn't have time to do the drag estimation because we didn't predict that it would be today. So that is it.
Oh, you're done?
Yeah.
Okay, fine.
We didn't do the drag estimation because we thought our presentation would be tomorrow. So
Okay. Fine. So, okay, Shamla. So, since you have shown your status, that is fine. Like, I'm status in the sense what you have done so far. That's okay. What you have not done, you can you know right how to do that part.
yeah. We're
Yeah.
already on it, but Raj isn't available today. He had the drag estimation thing, so he couldn't present it today.
Yeah, that is understandable since you thought your presentation will be tomorrow. That's fine.
Yes.
So you have sweep as 0 degrees. So sir has mentioned that is fine. Like as long as there is no sonic, as long as your airfoil does not reach sonic Mach number.
Mm.
So first we'll go with the questions. If others have any questions to Shamla. Any questions? Okay. So I have a question, Shamla. You have chosen your taper ratio to be 0.1, right?
Yeah.
So any particular reason? Because in core, what they mentioned
We did
is
a literature survey and we noticed that similar aircraft had a taper ratio of 0.1, 0.12 something. So we took we rounded it off and we chose it as 0.1.
okay, okay. So because in the core book, what they mentioned is the taper ratio. Like usually they choose zero point 0.4, or else if you have done some iterative scheme, then I thought you would have got
We
0.1.
came across four aircrafts, and all of these aircrafts, which had similar design criteria, had 0.1. These include ATR 700 Embraer and a similar aircraft. So,
Okay, okay, fine. Just a second, hold on. Yeah, Shamla, what about the flight Mach number? Yeah, what was the Mach number for your reference aircraft, Shamla?
uh, it was 0.42.
Yeah, then it is fine, Shamla. And also for your 3D lift coefficient slope, again the same thing. You can use your 2D lift curve slope instead of 2 pi.
Okay.
Yeah, you got CL versus alpha for your airfoil. You calculate the slope from that and slope of that,
Mm.
and you can substitute that instead of 2 pi here. Because 2 pi is from thin airfoil theory. Yeah, other
Okay.
things are all fine. If you have any doubt, you can ask Shamla to sir. He'll be answering.
No, nothing. Thank you very much.
Okay, fine then. Thank you, Shamla. Sir, should we proceed with the next group or? So we have only 5 minutes.